As we push toward decarbonizing our society, renewable energies are naturally propelled into the spotlight, yet their intermittent nature remains a vexing problem. Vexing until now, that is. Enter the holy grail called energy storage, which serves as the missing link between intermittent energy sources and reliable supply. Welcome to the session Energy Storage Takes Center Stage with Jim Fonger, who joins EBPowerCon to demystify energy storage and explain how it is an integral component of distributed energy resources and microgrids, plus the fact that it is yet one more exciting technology bursting with opportunity for electrical professionals. As Vice President of Asset and Advanced Technology Development at Ameresco Canada, Jim is responsible for all distributed energy resource and other asset development and deployment in Canada. He is also the current chair of Energy Storage Canada. And joining me now at EB PowerCon is Jim Fonger. Jim, thanks for joining me.
Anthony, thanks so much for having me on. Been looking forward to this.
Oh, and me as well. Me as well. I'm especially jazzed up to talk about energy storage, which for a long time I've seen as the missing link between reliable energy and the renewable energy sector. So
The
I'm
Holy
glad.
Grail is what it's been
Exactly.
described as, right? For renewable energy. Need that, the Holy Grail of energy storage.
Exactly. So to help better define what that holy grail is, and because I'm sure all kinds of folks have different notions about what could constitute energy storage, maybe just with
Mm,
your experience and with your knowledge, in your own words, you can kind of explain, well, what is energy storage? What things comprise energy storage?
right. Well, it's certainly a large question that would take a long time to go through all the details, but I'll do my best to try and sum it up. I
Uh,
think
we,
it
we
also,
we don't keep things easy here, Jim.
okay, that sounds good. Uh, Let me talk about it from the standpoint of I think what most people think of today when they hear the term energy storage. They probably think of batteries. That's what's likely going through some of the minds of our audience today. And while that's very true, energy storage, excuse me, has been around for some time. In fact, the earliest forms of energy storage are with hydro plants. So, Sir Adam Beck, for example, which is Niagara Falls, there's a huge area of water that basically sits behind the falls that can be released at any point in time that actually drives the turbines at the bottom of the falls to create electricity. And that in its most rudimentary form is energy storage. And so from that perspective, it's been around for a while. But in the context of batteries, certainly what's happened over the course of the last 10 years is the focus of manufacturing. It used to be lead acid, and lead acid batteries kind of were very rudimentary for the field. Could only store X amount of energy. There are lots of environmental issues attached with them. And where energy storage has picked up on the battery side is the development of the whole lithium ion, or we'll just call it ion battery technology, is really what's brought things forward in the last little while. Of course, what the issue has been is renewables, right? We're all trying to get to the stage of how do we transform into the new energy system that's going to get us off carbon fuels. And wind and solar have really, started to take off probably just after the turn of the century in 2005. But today, almost 20 years later, deploying a wind system or a solar system is the cheapest way to generate electricity. But the problem is you can't count on when it's going to happen, right? And so the whole concept of energy storage is really how do we regulate those intermittent resources so that we can actually count on them to provide the energy that we need. Now, that's not the only reason why energy storage is being deployed into the system, because not only can it actually provide value for the wind and the solar assets, it can also provide more value for the electricity system as a whole. You can move energy around load centers and basically have, make sure the load or that the energy is available in the load center where it's needed, not trapped somewhere outside in the transmission system that can get in. So energy storage can be placed simply to get load energy into load centers. The other thing is nuclear, for example. It's very hard to ramp nuclear up and down. That nuclear likes to run at kind of this steady state. And as you probably know, recently in Ontario, due to a large number of factors, we sometimes get into this period where we have excess electricity from the nuclear fleet. So instead of actually shipping that to the US at times when maybe we actually have to have them pay us for that electricity, it would be better to find ways to store that in Ontario. So that's all what's happening on the energy storage front.
Now, in terms of you mentioned Adam Beck, and it's nice to reach back into the past that way to get to some of our roots on the electricity side. But this is a grand, large scale energy storage system. What sort of other systems exist out there? Are we only looking at really large scale utility level things, or are we looking at possibly smaller forms of energy storage, community level or campus level,
Mhm.
anything along those lines?
Well, the nice thing about the technology, Anthony, is it really spans the gamut. It spans from hundreds of megawatts to gigawatts of potential in terms of energy storage, right down to what you may want to put in your garage if you're putting solar panels on your roof to more effectively manage the energy that those solar panels can come out. So there's companies like LG Chem and Tesla and others that are emerging that are excuse me that are making it possible for you to put 10, 20 kilowatt hour energy storage systems, in your house to be able to manage what's happening on your solar roof. And it goes anywhere from what you're doing at your house all the way up to those big gigawatt hour energy storage systems that are now being put in place. And the interesting thing is the size of your energy storage unit, both from a power and energy capacity standpoint, really defines what technology you're going to use for that application. So, for instance, it's unlikely that lithium ion batteries are going to be used in the long run for those very large transmission scale projects. There are companies like HydroStore, for example, that's working on compressed air energy storage systems, which are pretty much based around standard technology that we have today. And what they're doing is they're using underground caverns to basically store huge amounts of energy, basically under air pressure. And those are some of the very large scale projects that we can deploy on the transmission side without having to use up all of the resources that go into building a lithium ion on battery. So it really depends on what the application is, but they can go everywhere. They're not limited to where they can be deployed, and that means means opportunities for all kinds of people in the energy sector that are emerging that frankly are really not available yet today. They're coming online, but there's huge opportunities in this field moving forward as a result of it.
And that actually leads nicely to another question that I had for you in terms of energy storage. And I know there are multiple technologies and technologies still emerging, but have we gone past the pilot stage yet when it comes to some of these technologies? Or are we seeing these, being bona fide deployed, bona fide contributing to the grid? I hesitate to say, is it a mature technology, but are we there
Mhm.
yet?
What's interesting is Ameresco has this project in Newmarket, which is a 5 megawatt, 20 megawatt hour energy storage project. And it's a contract that we bid on and won for the Ontario Independent Electricity System Operator. And essentially, that project, which was called online back in 2014, that's where they kind of came to the market and say they're looking for a pilot. It is technically a pilot project, and what they wanted to be able to provide or demonstrate within that project is, can we purchase a large scale system like this, put it on a distribution grid, and be able to count on the fact that it can offer the same amount of energy storage and energy generation services on day one of the contract versus on day 365 of a 10-year contract, right? The concept is to actually show that this stuff is going to be reliable. And And what's interesting in that 5-year period from the kind of let's show what this technology can do to today in 2021, it's all breaks off on this stuff. It's being deployed as fast as they can actually manufacture lithium ion batteries. And as you've probably heard right now, we have some supply chain issues, both for automobiles and batteries, due to two things: all the new chips that they're having to bring forward to the controls, the intelligence that these systems need to run, plus the supply chain on the back end to actually deliver the battery themselves. They're being deployed so fast that the supply chain can't keep up with the demand. From certainly in terms of putting these technologies in the field, there's a whole opportunity to educate people who haven't done this in the past, to get on board to be able to connect up these systems, both small and large.
Interesting. Well, that sort of tells me right there that we've gone past the pilot phase if
Yes,
they're in
pilots
so
are
demand.
pilots are done, right? I mean, in Ontario, for example, there are thousands of megawatt hours being deployed right now to help large commercial customers manage their energy peaks. So it's definitely past pilot. These are no longer pilot projects, and it's here. It is no longer the holy grail, right? It's the solution to the problem that we've been waiting for, and it will make it really takes the brakes off in terms of us getting after the carbon problem that we have.
I do think and I do believe that it finally has taken center stage. It's finally truly in the limelight as opposed to just that thing that's still being figured out.
Yeah, well, if you look at certainly all the policymakers at the provincial level, at the federal level here in Canada, at the federal level in the US, and at the state level in the US, you've probably heard of the recent FERC orders, which are talking about the requirement for distributed energy resources that include energy storage to come online. And certainly events like what happened in Texas a couple of weeks ago in terms of kind of the problem with this macro grid that's out there today is, all of this stuff is driving for energy storage to be center stage, as you've discussed, and it's an absolute requirement for all these new system designs and renewable technologies that are coming out.
When you mention FERC in the US, are you referring to that order 2222?
Yes, it's got a lot of twos in it. I can't actually remember all the numbers, but yeah, you're right. That's it. And there's lots of conversation around it. There's lots of webinars in terms of people getting the understanding. And interestingly enough, many of the Canadian regulators at the provinces, especially in Alberta and Ontario, where we have kind of and I won't call it, it's a regulated electricity system, but it's decoupled, right? There's an opportunity for participants to play. So especially in Alberta and Ontario, that order, which basically requires utilities to ensure there's X amount of distributed resources with storage inside their systems. It's getting a lot of attention.
Interesting. And generally speaking, what happens south of the border will migrate its way up into Canada. So it's good to be apprised of these movements and these
Yeah,
initiatives. Uh,
absolutely. Well, it has to be, right. I mean, our electricity systems in throughout North America are very much aligned. So yeah, what one does, the other. It's all a group kumbaya, right? We got to do this thing together.
Exactly, exactly. Now, on the subject of, you touched upon it there with distributed energy resources and sort of alluded to the microgrids. I wonder if maybe we could spend a little bit of time just kind of figuring out and sort of defining for everyone, well, kind of what is a microgrid? What is a
Sure.
distributed energy resource? And perhaps, we draw upon your biography here, where you helped develop that, and I love this acronym, D-Boom business model for the I had to
Doesn't sound
Google
very
that.
attractive, but
I
yeah,
had to Google that. I'm like, come on, did
yeah,
he make this up? But
yeah.
perhaps against the backdrop, you could describe what went on with that London District Catholic School Board and what was developed there.
Sure. So a couple of years ago, NRCan, Natural Resources Canada, that's very much interested in finding ways to a low carbon future, put out a call for projects that would basically demonstrate the art of the possible in terms of two things. first of all, what could you do to existing buildings? Because there's a huge stock of existing buildings. What could you do with a project that would effectively decarbonize buildings? How do we get the old stock to a place where they don't have the carbon output that most of them do? And secondly, at the same time, is to find a way to build something that's going to be able to demonstrate some of what's this whole smart grid that the people are talking about. And I don't think it's the grid that gets smart. It's the controls you put around it and the people and the artificial intelligence behind it that gets smart. But essentially, what the opportunity was really to demonstrate the art of the possible on both of those fronts. And the visionary folks at the school board, of course, recognize that the students that are in high school today are going to be those students that are going to be required to take us the extra mile. Right now, you're basically getting countries committing to carbon reduction targets that we kind of have to be there around 2035, but after 2050, we have to be there, right? Or we have a bit of a problem on our hands. So it's the kids that are in school today, that the high school kids, they're going to be our industry leaders come 2040 that are going to have to take us that last mile. And their concept was, what better place to actually show the art of the possible today with this project? I think the view for the energy system of the future is that it really turns, I'm not going to use the word pivot because too many people are using the word pivot, but it goes in a different direction than what it is today. The electricity system, for the most part, is powered by large power generation facilities like hydro and nuclear that are, far out there in the field somewhere. The people don't need to spend, too much time thinking about all that power comes in on very long, expensive transmission lines and makes its way into load centers. And of course, centralized systems of any kind basically leave themselves open to a single point of failure, where you get one mass event comes along and it can take a whole bunch of infrastructure out. Again, I hate to use the same example twice, but look what happened in Texas. That's exactly what happened there. So where the future is putting energy right where it's used, and to basically facilitate the implementation of energy on buildings that can supply a good chunk of it, if not, all of it, at least some of it. So what a distributed energy resource is it's basically turning things kind of on its head, in that instead of having the electricity grid be the main power source that goes into a facility, and have a facility have, maybe some on-site generation assets that they can use in periods when the utility grid is not working, is really the building is going to have assets on site that's going to supply a majority, if not all, of the energy that it needs. And the grid is actually used as the backup. So distributed energy resources are going into distribution levels. So they're connected at the distribution side, the customer side. And the main purpose that they actually provide that customer are a couple of things. Actually, more than a couple of things. It's a few things. First of all, they're put there so that a customer has complete control over what their energy is, where it's coming from, and what it's going to cost for the long term. That's one of the great things about solar, for example, is there is no fuel cost for solar, right? There's no delivery cost for the fuel for solar. And unless something really strange happens in the future, the chances of the price for sun going up is not very likely. So you can put those systems in place, and all of a sudden you can lock in your energy supply for a long period of time. And of course, you can also reduce your exposure to future carbon taxes and be a good climate citizen moving ahead. So putting those resources on site and then integrating them into the grid, kind of the opposite way to the way the grid is planned, is where the big problem is right now, but we're finding ways to get around it. But a distributed energy resource is basically an energy resource that's connected to the grid on the distribution side. Now, where a microgrid can come into play, and what we did in London, is once you have those energy assets in place, especially on the renewable side, if you don't have any way to manage them, it makes it very difficult to interact with that grid. And in fact, it makes it difficult for the local distribution company to deploy those assets. There needs to be a control of those renewable assets on site. So that's where the battery comes in. The battery goes back to center stage again. it becomes the heart and soul of that system. And that's what we're basically doing at John Paul II Secondary in London, is we have a very large solar array. In fact, the solar array is oversized. It supplies over the course of the year more energy than what the school needs. And the battery is there to basically manage that in terms of how it's used. Those two things together give us the ability, if we want, or if the grid goes down, to actually say we don't need the grid. The battery inverters can actually form frequency and voltage, which means that it can form the grid, and we can operate that school in island mode for as long as we have the appropriate power to do that. So that's what that system demonstrates. And I think what the vision is, there's going to be thousands of those systems that basically start to come online, which does a number of things. It gives customers individual resiliency, but it also gives local area resiliency. And that's, it isn't just about what that, what we can supply for us. It's how can we interact with that local grid so that maybe some of the power we have at the school can be used for a subdivision down the road on the weekend that needs power as well, right? It's a matter of sharing that locally as opposed to coming from the outside.
Interesting. Now, actually, I'll just put the question rather than guessing. You had mentioned at the start that these current high school kids, they're going to be our leaders in 2040 and 2050. Is that high school outfitted now with any sort of energy monitoring systems or anything that the students can see, feel in terms of here's the cool technology that we've got in this school?
Yeah, and that's actually an excellent point. And one of the things that companies like us at Ameresco do is we always take efficiency as our first measure inside projects. And there are other reputable companies that do the same thing. But basically now, we can monitor electrical quality and electrical use right down to the circuit level. So there's companies like Circuit Meter out there who basically provide these very efficient ways to get down to a plug level, right? So you can monitor, is that printer taking extra power? That computer that was supposed to be turned off, was it turned off? All of that stuff now is being installed into load so people can understand what's happening there. In addition, there's CO2 monitors, there's fresh air monitors, there's scheduling in terms of the building. Now we have all of these technologies that can be put in place that make sure that a piece of artificial intelligence that's programmed correctly on the outside can actually make sure that that building is using what it should be using based on what it should be doing at any one moment in time. So now that you've got all those, all of that data that's basically being used to run the system, all that stuff can be put up on screens, right? So part of what we have at the school is there'll be screens that will go up that will actually have different colors that say we're actually off grid. All of our energy is coming off the solar system right now, or we're off grid. All the energy is coming off the solar system to run the school. And by the way, we're also exporting, 200 kilowatts out to the grid because somebody else needs it. All of those information kind of components will be available on the screen, and they'll also be available on the internet, right? So that if students want to be able to log in and see what's going, or you need to demonstrate, all of that stuff will be available. And it was a big part of this project, right? I mean, it's all very well to go by the school. It looks great because it has lots of now covered parking with ground mount solar, which looks great. So there's lots of things you can see, but it's the results that you need to be able to provide to the folks that are inside the school, and so those students can see what's happening. I guess the other thing, Anthony, that this is not our core competency, but it's something that we would like to bring to the project is some curriculum so that people understand what it took to do this, the business case behind it. And we're also hoping, right, that we can work with colleges and universities and trade associations to make sure that once you've got a project like this, that people can really put their hands on. And that's why we wanted to do it. People needed to see that this worked, that it could be deployed in a real live situation, right? Supplying a school that actually needs energy, that it is reliable, that there's not going to be all these bad things happening behind it. But once you get to that stage, that's where where people can see it, they can hear it, they can touch it. It really starts to take off, and we're hoping we can use that project for that.
Oh, that's exciting, very exciting, and it's sort of It kind of makes me figure that I don't need to even put forward this next question in terms of energy storage being a passing fancy because I think it's here to stay and only growing. But I thank you for giving that example and showing how these things sort of intertwine and their relationship to one another. But one final discussion point is, we're talking about electrons moving this way, that way. If you could maybe talk about some of the opportunities that are available in energy storage, whether large scale or small scale, for electrical professionals in
Mhm.
Canada.
Well, we can speak from experience in terms of working on all the projects that we have right now. All the ESA folks are involved, which means there's codes and standards. We've had electricians on the job. We've had electrical engineers doing the design for the project. And this is high voltage stuff for the most part. Even when you're working in your home, for example, when you're working on energy storage devices, you're stepping up from that 100 amp circuit to the 200 amp or the 400 amp circuit. These are all systems that have to be installed by professionals who really understand what they're doing. Uh, First of all, to keep themselves safe, to make sure that it's hooked up the right way, so that warranties are maintained by the product manufacturers, so that they perform at the proper efficiency levels that the system was designed for, and that the longevity can come out of them that's required. And unless you've got trained professionals that really understand how all this stuff works, is that's the foundation of your projects, right? If that's not done correct out of the gate, then companies like Ameresco, who like to stand behind this project and guarantee the outcomes, we're in trouble unless we have people working with us who know what they're doing. And as we talked about earlier, this is just getting started, right? We're early days, and there are tremendous opportunities in terms of, as our prime minister says, building back better. The whole thing after COVID, many of the incentives and works out there are to address our climate crisis, find ways to put people back to work, and find ways to put them back to work that's sustainable for the future. Because what we're doing now is what's going to happen down the road.
Very good. So lots of opportunity across the country. Um, I have one final point, and it was just on the tip of my tongue, so you'll have to bear with me, Jim, for one second. Oh, yes, I remember what it was. When it comes to electrical professionals who want to learn more about energy storage, perhaps some of the players involved, and start building their own networks. And here's where I want to give a plug for you as chair of Energy Storage Canada and the Association Energy
Mhm.
Storage Canada. Maybe you can tell me a little bit about that group.
Sure. So Energy Storage Canada is a very small organization, but it has lots of members behind it. Its main purpose right now is on the policy and advocacy side. This whole concept of turning the electricity system and have it operating a bit differently requires lots of advocacy at the government level, at places like the IESO, and others, to get them to understand what the advantages are of this thing moving forward. And energy storage is Canada is still reasonably new in terms of its formation, but our executive director Justin Rangooni is growing it, and we're in the stage right now where we're looking at taking on more personnel so that we can start to set up educational programs exactly like what you're talking about. For someone who really wants to understand energy storage, what are the opportunities, right? They should be able to reach out to an organization like Energy Storage Canada here in the here in Canada, and the Energy Storage Association of the US if they're in the United States. And the two associations are very much aligned in terms of how we're providing assistance to those companies interested in energy storage. And so we're this year, for example, we're looking at setting a working group for Canadian manufacturers of energy storage systems. The Canadian government has actually announced that we have all the raw materials in Canada to produce battery cells, and here we're in a situation where there aren't enough battery cells being produced around the world. So it seems like it should be a pretty good opportunity for us to get some of this stuff going. But it's the same for people who want to learn. Yeah, reach out to Energy Storage Canada. Justin has lots of resources that he can send out to folks who are interested in learning more about the topic.
Jim, thanks so much for a truly engaging conversation and helping demystify what energy storage is, where it's used, the different applications that can be a part of, and for reinforcing that opportunities abound and will abound for electrical professionals in Canada.
Well, it's been great spending some time with you. The time seems to have gone awfully quickly. It's an area I'm very passionate about. It's very exciting, and there are lots of opportunities for all of us to get to work and figure out how to get ourselves on the other side of this climate crisis, because we can do it. We just have to get going.